Today we're going to look at solving absolute value equations. And it's a good place to start by reminding ourselves what we mean by absolute value. When we talk about absolute value, we're talking about the distance from a number to 0 on the number line. And in the same way that it doesn't make sense to say that you walked -2 miles to school, distance can never be negative. Distance is always either 0 or positive, and so it is with absolute value. So as an example, if we think about the number 3, it's 3 units from 0 to 3 on a number line. So the absolute value of 3 is 3. It's also 3 units from 0 to -3. So the absolute value of -3 is also 3. Think about an absolute value equation now. We're going to say that that's an equation and it's going to be in the form of the absolute value of x equals c, where c is greater than 0. This type of equation will have two solutions. C and the opposite of c. Important thing to remember is we need to solve two cases. We can't just solve one and then make that answer negative. So to remind ourselves, the absolute value equation, absolute value of ax plus b equals c, where c is greater than 0, is the same as saying this compound statement, ax plus b equals c, or ax plus b equals the opposite of c. As an example, absolute value of x plus 4 equals 7. Well, this expression, whatever it is for x, if it's equal to 7, if I take the absolute value of 7, that's 7, right? Conversely, if x plus 4 is equal to -7, whatever x makes that happen, well, if I take the absolute value of -7, that's also equal to 7. I would solve two equations. X plus 4 equals 7. I would also solve x plus 4 equals -7. When I go to and solve those two, I'll have these two solutions, 3 and -11. Note, not 3 and -3. We can't just take that first solution, 3, and take its opposite. We have to actually solve two equations. So let's take a look at what that looks like. The absolute value expression, 5 minus 2x equals 9. Well, if 5 minus 2x equals 9, the absolute value will be 9. Or 5 minus 2x equals -9. That result will also give me an absolute value that's 9. So let's solve those. To get x by itself, first I need to subtract 5 from both sides. Don't lose your negative sign. Opposite of 2x equals 4. So divide by -2, and x equals -2. It's one possible solution. My other solution, I subtract 5 from each side. Opposite 2x equals -14 now. Divide by -2. X equals negative divided by negative is a positive 7. What about checking my answers? Five minus -2 times -2, that's 5 plus 4 equals 9. Absolute value of 9 is 9. Check. How about if I use 7? 5 minus 2 times 7, so 5 minus 14 equals -9. And the absolute value of -9 is 9. That checks as well. So that was a basic example. Let's take a look at one when we have a little more complicated situation. 3x minus 9, the expression is inside the absolute value bars. Outside the absolute value bars, negative 10. I need to isolate my absolute value expression first. So 3x minus 9, absolute value of that, minus 10 equals 14. I'm going to add 10 to both sides. 3x minus 9, absolute value of that expression, equals 14 plus 10 is 24. Now I can show my two cases. 3x minus 9 equals 24, or 3x minus 9 equals negative 24. Let's solve those. Add 9 and add 9. 3x equals 33. And then x equals 11. My other case, I'll add 9. Negative 24 plus 9 is negative 15. So 3x equals negative 15. And x is going to equal negative 5. So important to point out, I had two cases. I will have two solutions. Let's continue on. It helps to get a handle on the concept of absolute value equations by working one backwards. We're going to get into this up to our elbows on this trip through. Write an absolute value equation that has negative 4 and 10 as its solutions. Well, let's think about what that would mean. I'm going to end up with x equals negative 4 and x equals 10 as solutions. Well, where did I start with? I had the absolute value of some expression, x minus a number, is equal to a value. So when I have this situation, once I break this down, I'll have x minus a number equals something, or x minus that number equals the opposite of that same something. So this at least gives us an idea of where we're going to begin. Let's take a look for a second at that number line again. So here's negative 4 to positive 10 on a number line. And we asked ourselves, what is this distance? Well, from 0 to 10, that's 10. From 0 to 4 is 4. This complete distance is 14 units. Okay. Now I'm interested in thinking about what's the midway point. 14 divided by 2. I'm going to take the average of 10 and negative 4. 14 divided by 2 is 7. So the midpoint of a 14-unit distance is 7. Well, if I start at negative 4 and count 7 up, 1, 2, 3, 4, 5, 6, 7, I end up at 3. Similarly, if I were to start at 10 and count back 7, I would end up at 3. So my midpoint is 3. If I start at one of the extremes, my distance to my midpoint is 7. When I set up my absolute value equation now, I'm going to go x minus the midpoint equals the distance. X minus the midpoint equals the distance. So x minus 3 equals 7. Let's see if this works. X minus 3 equals 7, or x minus 3 equals the opposite of 7. Solving these, plus 3, x equals 10. Or, plus 3, x equals negative 4. I can see that those are the answers that we were shooting for at the beginning. So the steps on this. Determine the distance between the endpoints. Take that distance, cut it in half. Use that to find the midpoint. We're interested in two things, the distance to the midpoint and the midpoint itself. When we write our absolute value equation, it's going to be x minus the midpoint equals the distance. Then we can set up our two equations and solve. Finally, let's take a look at a word problem. So, kind of an obscure word problem, not something most of us would try to solve, but it does give us an opportunity to use our skills at solving absolute value equations. The solutions of absolute value x minus 12.41 hours equals 6.94 hours gives the number of hours of daylight in Anchorage, Alaska on the longest and shortest days of the year. Solve this equation to determine the lengths of the longest and shortest days of the year in hours and minutes. So we have x minus 12.41 absolute value equals 6.94. 6.94 is our absolute value. So if x minus 12.41 is equal to 6.94, that's one possible case. Our other case is x minus 12.41 equals negative 6.94. Not a bad idea to go to your calculator here. So 12.41 plus 6.94 is going to give 19.35. The other case is we add 12.41 to both sides. 12.41 minus 6.94, 5.47. We're asked for these in hours and minutes, so we're talking about 35 hundredths of an hour. That's 21 minutes. So 19 hours and 21 minutes of daylight on the longest day of the year in Anchorage. Similarly, 47 hundredths of a minute, 0.47 times 60, is going to be 28.2 minutes. We'll call that 28.2, 5 hours, 28 minutes. So how we could use an absolute value equation to solve a word problem. When we get back together next time, we'll take a look at solving absolute value inequalities. And as a preview, we'll find out that that's just solving a compound inequality.